Hey guys. Alright, so 4.6 talks about Kramer's rule. This is where we kind of bring a lot of things together and the fact of how matrices are applied in algebra and whatnot. We just got done the last chapter solving a bunch of systems of equations, things like that. This is what it is. Kramer's rules is another method of solving a system of equations. Okay, so just kind of write down the the algorithm. X is equal to the determinant divided by a determinant here. So let's see, X is I'm sorry, this should be B. I have FD. And the bottom one, and the denominator here is always going to be the same for the x coordinate and the y coordinate. So when I evaluate this, and notice where I get my coefficients from, okay, and I just plug it into the matrices, and then I figure the determinant here, okay, in each one of this. This is really a really simple concept here, not very difficult at all, okay. This is my x coordinate for my x and y ordered pair. Okay, x, y ordered pair that satisfies this. This is my x value right here. Just evaluate that, and you get it. Okay, my y coordinate now is like I said earlier, CD. This denominator is the same. Now what changes here is I replace this column. I replaced this column with the solution column, so I end up getting AC, and then EF here. Okay, so I kind of notice how how this kind of works, how I come up with the numerators. Okay, with respect to the coefficients in the system of equations here. All right, so this is called Kramer's rule. Again, it's applied, or the application of it is using it to solve a system of equations. Very applicable, in that aspect, in Algebra II. So when we need to solve a system of equations, this is another method that we can go about doing it. So let's see if we can't do an example here. Alright, I have a system of equations. Lucky for me, it's already in standard form. Both equations are looking pretty nice. So that's number one goal that you'd have to do. If it's not, you have to kind of put it in this form to where, your x's, your y's, and then obviously your solutions to one side. Okay, so both equations need to be in standard form. So now I just need to plug, corresponding values here with my coefficients. Okay, where do I put those? Well, it should be a kind of a common sense algorithmic type thing here where you just kind of follow along. So the bottom one is just going to be the coefficients of your x and y's right here. So it ends up being what? 5, 4, 3, and -2. Okay. Now your top one ends up being, your solution column, and then your solution column, and then BD, which would be your y. So I have 4 and -2 here. So that's my x. It's my x value. So I need to, I evaluate that. Now I'm gonna kind of smush this so I don't lose you off the screen here. Again, the same thing here, so that's convenient for us. It'll be the same value as that. But this one up here will be different. So up here I'm going to have 5, 3, and, well, then it'll be the solution column, so it'll be 28, 8. Alright? So now all I got to do to evaluate this, or to solve the system here, is to evaluate these matrices, or these determinants. Okay? So, and then divide, obviously. So, let's kind of go ahead and do that, I guess. I have, for x, my x coordinate, I'm going to have 28 times -2, which is negative 56, minus 32, because 8 times 4 is 32. So in this particular situation, I end up getting, on top here I get, that's negative 88. Now on the bottom here, so this right here is negative 88. Now on the bottom here, I got to do the same thing. So I get negative 10 minus 12 is negative 22. Well, I'm dividing. So I divide this. Well, that's kind of convenient. It kind of turns out to be 4. All right. So my x coordinate right here is 4. All right. So a couple different ways. I go ahead and solve it using the determinants here, or you can even plug 4 back into one of the equations and solve for x that way as well. It's whatever easiest for you. So again, I guess I would go ahead. This is pretty simple here because the bottom part's already done for me. So I'm sitting here with y equals negative 22 on the bottom, because it's the same as this. This determinant is the same as this determinant, so same value. So the only one I have to really evaluate is the top one there. So I get 40 minus 3 times 28, 28 times 3. I get 24, 6, 84, minus an 84. I get a negative 44. Divide by negative 22. I end up getting a, what's that? Positive 2. So in this particular case, I get 4, 2 for my answer here. 4, 2 for my answer. So that's how you use Cramer's rule on solving a system of equations. All right? Pretty convenient way. Now, can we use this as a, with a 3-variable equation? You bet. Okay? And I'll kind of step through a problem with that here in a second. All right? All right, rather than giving you an example over a 3-variable a system of equations, let's just kind of stick with the try this problem, and maybe we'll kind of go over a 3-variable tomorrow for like a beginner lesson type thing. So let's do that. So let's try this problem here. It's in red, so hopefully you can see it. It looks pretty good on the screen. So it says try this. The first equation is x minus 4y equals 1. The second equation is 2x plus 3y equals 13. Okay, go ahead and solve that using Cramer's rule and see if we can't use that. Very useful method. So, good stuff.